And the truth is, as I went over this, I thought, okay, this could really, I could see some needs for updating some of this content and fleshing it out in some regards. So I'm actually gonna do something a little bit unusual for this class. I'm gonna more talk to you today, but walk you through things. But we'll have some dialogue about specific issues here, okay? So we've been going through best practices of various sorts, and one of the most important, I can't think of any one thing more important than it, is peer reviews. Why do we do peer reviews in their many forms, whether it's pair programming, formal inspections, peer reviews of pull requests, just simple desk checks where you ask someone to have a look at some code. Why do we do them? Like why are they so important? Why do I say they're like, I don't know of anything else that's more important? Yes, Jason. Yes.
Yeah.
Clock is right twice a day. Yeah.
Knowledge dissemination.
Okay, that's a key goal. Yeah. You might not think of it as like the main goal of it, but it's an absolutely central. If it's not the main goal, it's an absolutely central sort of side effect or extra benefit. But that in that way, it's it offers arguably as much value as like finding defects or finding problems. What other are reasons that we do this? Oh, okay. Ronan?
Yeah.
Okay.
Yes. So I got really excited.
Yeah.
Yeah, I would say like you're going over code that meets like all of those, you could say like solid principles and checking over it, but then you're also like going through it with the author of that code to then kind of learn from, like you're not pointing out what's wrong, but you're like helping them learn a different way to.
And learn about what? Like what set of things might they learn about? So you're absolutely right. And I'm asking a bit of a trick question. Learn about. Okay. Yeah. So learn some principles of coding, but there's a lot more. There's actually, learn about style, learn how to use better another aspect of the API or, the API provided by your system or another one, how to use the database layer more effectively, for example, learn about logging. How to do use of logging or assertions, more effectively use mocking. And to the degree, like peer reviews of pull requests, you will often stipulate that they have to include tests as part of them, to have more thoughtful tests. So there's a lot of learning going on. How about another reason? Yes, Rob.
Yes. What about like if you're getting the developer to explain their code, like in regular language and just say what they're trying to do as a way of like maybe kind of like simplifying or debugging kind of thing, like the logic of what they're doing, and then
Good. Forcing sort of reflection on what's been produced. And in a way, it's a matter of disseminating information to others, but it may also be building up understanding on their part, which then gives them new clues about how to test it more effectively, or how to improve its efficiency or something along those lines, right? And finally, I'll just mention the obvious one, which is, okay. Hold on. Do you have a brother in this class? Yes. I'm getting your two names confused. Oh gosh. So Ron is your brother. Okay, I give up. Randall. Thank you.
I did notice.
The R's are strong.
Yeah.
Yeah, no, this is real good, don't forget Ron. Yeah,
I did notice like peer reviews and fair programming just gets people.
yeah, that's. Say it ain't so, yeah, that's true, you know, to a degree of accountability, like you have a peer review schedule, you kind of want to have something to talk about there. You do pair programming. Okay, you got to roll up your sleeves and get something done. So that's kind of like having an accountability partner or set of accountability partners. You have others who will be joining in, forces you to get things done. I mean, it's one of the reasons meetings get scheduled, because you have a meeting, you know, you have to do something before that meeting for it not to be embarrassing, right? And so it gets you to do things. So that's good. And it gets you to do things with a certain compunction, a certain quality. If you know other people are going to look at it, right? You might not take certain liberties or shortcuts that you would otherwise, right? Because you know other people's eyes are going to be on this. And they'd say, like, Randall, my man, like, you know, that, you've never, like, do all your exception handling have empty, you know, empty blocks for the exception handler, or is all you do is dump the stack and bomb out? Do you know about like rethrowing another exception, or do you know about closing file handles or something? So yeah, it can force you to be more circumspect in your coding, because you know the eyes of the world. Well, if not the world, then at least your fellow teammates are on you, right? So that's really important. But kudos to you. Kudos to you. That's great. It was worth struggling over the name. Good. So peer reviews offer many benefits. In fact, you may be surprised, but formal studies of them, where they compare like side by side teams working with formal inspections versus working with an emphasis on testing, has shown that they actually can find a larger fraction of defects, of known defects, than testing. And they're actually more cost effective in terms of personnel per defect. Now that's not obvious, right? Because peer reviews take time. Their program requires 2 people instead of 1, right? Formal inspections require, you know, a bunch of people to come together for an hour or 2, and it may seem, why is it that they can actually be more efficient than testing? Because you might think about automating testing, and you know, it runs every time a build goes on upon, you know, pushes to the system, and potentially even upon commits, you know, locally. That might seem almost for free compared to sitting down and going through code that may eventually evolve. So how is it that it could be actually more efficient? Anyone? Why could peer review be more efficient? Why is it? Sorry, can you hypothesize some reasons? Yes, Jason.
Well, this is one reason, but if you find the problem earlier, it's a lot less expensive.
Excellent. Yeah, remember that exponential graph I drew? And if you find it earlier, maybe a lot fewer tests are written around it, a lot fewer lines of code elsewhere in the system are written around it. And it may be that there's less ripple effects for changing, right? So that's really good. Why not? Yes, Randall.
Some people can see things that we can't.
Yeah, okay, so that's right. So others may be able to find problems that you can't find. Now, testing also finds problems that you might not be able to find. So So it is true, for peer review, that's a virtue. Upon these things. Testing does find issues, but often the testing that finds issue comes from someone else. Not always, but developers have a way of testing their code sympathetic. They test to show that it works. Whereas testing written by others often zeroes in on finding where might it be failing. And often developers aren't quite as good at that. Connor with me.
Maybe it could improve like efficiency, it's like somebody like sees something and say, like, why are you doing it that way? You could do it this way.
That's true. That is a huge benefit of peer review, and it's a huge element of learning. Here we're actually talking about defects, but that's a key asset. But I'm gonna give you a slogan. I want you to remember this. This slogan is often on the final thing. I know. What is it? Kind of overdue. Here's the difference. Peer reviews. So testing finds failures. It finds cases where the system doesn't seem to behave right. Right? You agree with that? It finds things where the system fails in some way. Maybe it crashes, maybe it tanks, maybe it, puts the wrong thing on the screen. Maybe it leads to some output that's already there, not being relevant or whatever. It leads it to do the wrong thing, right? It leads to failure. What do you do when you see a failure like that? Well, okay, you report it. It's an issue. It gets reported. Is it fixed then? What has to happen before it's fixed? After you find a failure, identify the failure, what do you have to do? There's a process. It has a name. Well, okay, you report it, so that's good. That's a key thing. Make sure it's reported. Okay, there's a follow-up, but there's actually a process. It begins with D. Debug. You debug it, right? And that process of debugging tracks down the underlying faults that cause it. Find why did this happen? And you find, oh, we forgot to update this table this field. Or we forgot to initialize the variable. We returned the wrong variable from a function. You comfortable with that idea? So testing finds some failure or some situation where the program doesn't behave. It misbehaves, right? And then someone has to debug it. Debugging takes time. It takes serious time to debug. Peer review, so testing finds failures. Peer review finds faults. It actually finds the underlying problems. Peer review, in peer review, you're reviewing the code and you actually spot an underlying problem. So the defects you find in peer review are often the underlying problem that would otherwise have to be found by not just testing, but debugging, which takes a long time. Not always so. You find lots of other things. You find ways to make it more efficient. You find ways to make it more clear, more elegant, more evolvable, extensible, modular, all these good things. But when you find a defect, you're actually finding the underlying fault, not merely a failure. Or very common, that's the case in peer review. So you cut to the heart of it instead of having to try it and find a failure and then have someone go and track it down and figure out for all the important logic, oh, that's where it is. It's an uninitialized variable. So it turns out that's one reason it's more efficient in terms of fixing. Sometimes you also learn from it, right? You find one defect and then you start learning, oh, there's other places like this in the code. I didn't realize it doesn't initialize this automatically. Now we have to go find these other things. So it turns out they kind of pay for themselves. Peer review, the time spent in peer review pays itself back in time avoided in testing. And it's actually more flexible than testing. What's one thing you can do with peer review you can't do with tests? Well, we can learn about things like efficiency, modularity, and improve the quality of the code, and all those good things, but we can also do testing, or what is testing run on? Testing runs on, what do you test? Do you test requirements document? Can you run a test on a requirements document? Can you run it on a design? On a testing plan? Could you peer review those? Yes, right? You certainly can, and you should be. I hope you are. I hope. Inspections can start soon on things like requirements stuff. Testing plans. First ideas in place for where the interfaces might be between different parts of the system. Because those things can be done early. And such reviews often pay off for reasons that Jason articulated. The exponential curve, finding them early. If you find a requirement that is misunderstood, that can save you all sorts of ways, all sorts of rework. Where you have to go back and do it, or the team, different parts of the team still remember the old one and work across purposes, yeah. But the truth is, I'm framing it as like better than testing. The truth is the two work together. Why do they work together? What can you do with testing? How is testing synergistic? How does it sort of work jointly with to deliver value all greater than the sum of the parts with peer review? Why do they help each other? Give me a reason peer review can help testing. I'm going to pick on this. That doesn't sound right. I'm going to hear from this gentleman, and this gentleman, he has a name. He's not like the horse without a name. And I'm trying to recall that name. Colin, I think is his name.
Right.
Okay. Yeah, so Colin, speak on them there.
I was gonna say this, I guess you can peer review your tests, because you have a bunch of tests and you've got to make sure the tests actually are doing what you think they're doing, the tests
Yes.
themselves.
Yes.
You can't test the test without having people peer review it.
Yes. Yeah, I mean, peer reviewing of tests can really improve the tests. It can find problems with them, but it can also give ideas for how to test more effectively. Because we can't test exhaustively. It's a rare system. Only in the most contrived cases can we test this system exhaustively. And so our job in testing, we'll be talking a lot about this in this conference. Our job in testing is to figure out how to get the biggest bang for the buck. For the time we're going to put in, how can we test most intelligently? Find the bugs that matter as quickly and efficiently as possible. And that's not easy. That's not easy to do. But peer reviews by reviewing tests can give really good ideas of, oh yeah, if I could also test this, or I could look for that, or this is a smarter way to do that, which would let me get, the ability to further evolve this test, or make it more of a test that is likely to not require change as much over time. One thing I didn't talk about here is I was putting out there a kind of straw man argument for tests that, look, tests can be automated. You run them every build, et cetera, and that is true. But there's a secret downside to it, which is that tests have to be maintained. And as the system evolves, think the UI for the system, for UI tests. Think about the API, if that were to change. Think about unit integration testing, if now pieces of the system change, then the test may break, right? Now you have to pass another argument to this function or something, and now you have to revise the test, and that takes time. Probably not. And so that's one of the reasons tests require more time. So the Colin is not done right. You can review the tests. What's another reason that testing can benefit from peer review? Hard left that hand up over there. So what's another reason peer reviews could benefit testing? So you can peer review the test, what else?
Find new ways to test.
Yeah, gives you ideas for things to test. There are some things when you're doing a peer review might be really hard to think through. And you'd like confirmatory tests on them, right? You'd like to have tests that will evaluate this. Maybe it involves multiple levels of the program and you want to be able to test, does it handle this out of memory condition properly, or the disk space is out, or, you're having an exception thrown and you want to make sure that the database connection is properly closed. And it's hard to reason it through. And so you'll run you'll build a test that will confirm. Understand. So what's another reason that testing, so that's excellent. What's another reason that peer reviews can help testing? Well, I mean, the truth is I was going to list these things, and I found that I had like 30 reasons why it could help, and I couldn't list them all, but some sense, right? You can do inspections and test it. That's what young Collins said. You can lead to changes that lead to separation of concerns and code modularity, and that aids testing. Remember this whole idea, if it's all a hairball of code, the UI together, the business logic together, the database, testing, one of them means testing everything. And it means somehow winding your way through it to test certain things. It's almost impossible. Modular code, ladies and gentlemen, modularity, I tell you, modularity is a key to good testing. You divide things up into specified pieces, abstractions that have certain jobs to do in life, that need certain information they take in to do that job, and accomplish that job in a well-defined way. They accomplish something clear. And that allows you, allows you to test it effectively. Take it from an opening. So peer review can allow us to identify opportunities for modularity, which indeed raises and separation concerns, which then lets, in a kind of virtuous cycle, us to then test more effectively, which can give us sometimes ideas for area of the code, which are kind of janky, kind of soft, which we can then peer review. Think about that. You can improve ways to improve testability of code, right? Related to modularity, but maybe where mocking would be a really good opportunity for mocking. You could put in assertions, identify with peer review where assertions could go, or good logging could go, right? That could aid testing that, and that can improve the code as far as its testability. Resolution of defects found in inspections can then be verified with tests, which then go, having fixed it, it would go in your what test suite. Begins with R. Has a G in it. Regression testing. Thank you. Like that Greek course. That's okay. Peer review can give ideas for tests, right? If you go through it, it inspires ideas for testing, right? Spotting suspicious features. This is kind of a true Shankian idea, right? Right? With a name worthy of it. Yeah. Indeed. And it can suggest things that testing can, okay, this is kind of the other way now. Testing can suggest things subject to peer review, right? Like again, you're finding it's kind of slow in this area of the code, or sometimes it behaves erratically, or sometimes it fails, but most of the time it doesn't. Good time to spin off an inspection related to it. Peer review could allow for removing of defects, blocking the discovery of other defects. That's a big issue with testing. If one test fails, if there's a failure of the code at a certain point, it blocks the execution from going on from there. And that can hide, I tell you, other later defects, because you can't reach them. You don't know what lies beyond there for testing because it's not reached. And by removal of defects with peer review, you could go through and let that code continue and test more fully, get greater code coverage. Hmm? And you can identify problems in the design that are leading to problems with failures in the system. The design, like the requirements, or like the test plan, cannot itself be tested, but it can be peer reviewed. Hmm? And that, ladies and gentlemen, is of great significance. Okay, so what are peer reviews? It's important to understand. Peer reviews are not, they're not reviews of peers. You're not, pulling someone aside and saying, bro, my man, we need to talk. No, these are not reviews of peers. These are reviews by peers. Of areas of technical, of artifacts, of pieces of the project. And they don't have to be executable. And it's very important you realize that, because some of the biggest ticket benefits come from testing or from peer reviewing requirements and test plans and design documents and test matrices and lots of good things. What we're going to be doing soon, like TA and I, for your projects, you should be able to do sooner than we review it, so that what we review is higher quality. Take that advice as well. Okay. Now, reviews come in many different forms. Some of them are really lightweight, quick. Some are more, require more attention. Maybe like peer reviews of pull requests were at least reviewed by 3 reviewers is required, and there's tests given there that have run successfully, etc. And to all the way to inspections, which are as formal as they get. But remember that all of them have their role, and pair programming has a really big role. So I think we talked about it, but Jason put it forward. This is really about learning. It helps learning. It's not only about learning, but it helps learning greatly. It helps learning by the person who created the artifact, or the person reviewing the artifact, and broader culture, the spreading of knowledge, spreading of coding conventions, spreading of style preferences, etc. So, I've shown this here, which is from this great book by Wiegers on peer review, and he puts forward in the book, Carl Wiegers, these different areas of the system on which you can do inspection, peer review, including peer review with inspection things, type of peer. And I'd like to have this up here, not because the detailed structure is super important, but just to bring home the number of different types of things you should be thinking about when you think about inspections. One of the tragedies of this class is that often teams secure the benefits of peer review late in the semester only. And they confide to me how much they wish they had done them early and done them often. I require every person here to have an artifact that is reviewed, and each deliverable from ID1 onwards, make note, must have at least one inspection. So I'm going to be looking at this. In case any of you are wondering, that's not part of the feature freeze. You could do those late. But it's good to do them early, and you should be thinking and realizing that in ID1, you could be reviewing many things, including requirements, any thoughts on, the specification, any thoughts on testing strategy, right? With gherkins versus with, lower level testing, use of Vite or what have you. You could be peer reviewing the guidance that you folks are giving to bring people up to speed on how to use certain technologies, right? You could be reviewing your style preference document or what have you. So you really want to have in place reviews of a broad range of features here. Okay. And this includes doing, UI plan tests like you might do in Figma, right? For prototypes, wireframes, right? You want to get those in place. Now, I do want to talk a little bit about making effective use of it. This may sound obvious, but it's really important. So I'm gonna, forgive me for emphasizing something that some of you may know in the phone. Look, you want to keep these reviews impersonal. This is not a witch hunt. This is not an attempt for one person to show they're a better coder than another, or one person to show that they know how to program in X better than a different. The goal is, how can we as a team improve our artifacts, and how can we improve our process to empower people so that we can spread knowledge and spread understanding? How can we do better in our work? It's not to find where the problems are with your particular check-in. It's, how can we do better? What can we do to improve this further beyond the work that's already been done? This is really important. If it turns into sort of contentious thing, I believe my code is good quality and you're criticizing it, it's not going to accomplish it. You want people to be rowing in the same direction and realize that this is about how can we do better. And just because there's a problem found in your code doesn't mean it is fundamentally your problem. It may be fixed by spreading better awareness of how React works, or understanding how Vite works together with JavaScript, or how the Oculus API works. So, there's often thoughts here that come out in how can we improve the processes? How can we improve it to find these sort of defects in testing, for example? Often you want to use basic things like linking and code style tools before the review, so that the review isn't spent just stating things that could have been found, right? So if you do the linking, if you do the code style checks before, you can focus that limited time on other things that require more human attention. Asynchronous reviews, like for pull requests and merge requests, same, are excellent in our industry standards right now. And you want to keep the review team reasonably small. I wouldn't suggest going over 7 people at most. Importantly, and this is important, your goal in the peer review, in the inspection, and I have in mind, because that's required of you, is not to solve the problem. It's to bring up issues to be looked into or to be eventually fixed. It's to put things on for a possible resolution later, possible study later. You're not trying to solve them there. If you start talking about all the solutions for everything that comes up, again, it won't be the best use of the time. Keep the meeting limited to no more than 2 hours. People burn out, and for formal reviews like inspections, I would strongly suggest having people look at it before coming. Why look at it before coming? Why look at it before you arrive? Yes, Kevin. Yeah, exactly. You've already got learning going on, and often people will come there with certain questions or certain confusions, right? They'll come there with certain thoughts, and you can use the time much better. Yes, people could review it there, but it's not using the time as effectively. And you want to be sensitive to the sort of culture and the human side. Software engineering, software development is human people. There's a human element, you want to be attentive to that. I don't think this is gonna happen in your projects, but there have been a few cases over the years, over the almost 20 years of teaching this course. I know 2 instances where like peer reviews have turned into conflict-laden episodes. Someone stalks out there, criticize, you know. This code is code rocks, its efficiency is better than anything you could write. There's something, stupid. I mean, it's a pointless exercise to have it that way. And so you want to be attentive and you want to say again, how can we improve our game? Same thing with retrospective following deliverables. The question is not to find a witch hunt, why didn't that get checked in on time? It's how can we do better as a team? What can we do that will help us do better at the next delivery? And if you approach it in that way, that's not pointing fingers, but finding ways we can improve our process, you can use the time often much better. And ultimately, you do want to focus it on major issues, not the most minor types of style, which is why you want to, get basic style things done. That doesn't mean you can't mention style, it's fine. It's just that if it's already passed through that and those things have been fixed, you can focus your time on more substantive areas of feedback, yes. So who to involve? Well, look, if you need reviewers of pull requests, or you want to invite people to inspections, it's really good to think about who comes there. For example, the author. Well, I say here, of interfacing deliverables, dependent deliverables, predecessor. What have I talked about here? Like if you have code that is being reviewed in that case, who might be others that might come there to good effect? When I say like predecessor or dependent, I just want to make sure that I'm communicating something meaningful to you. So if you have some code, and I'm reviewing blob A, who might be good to have there?
The author.
Good. The author of A is very good. Indeed, not to be minimized. I mean, that's absolutely central. Who else? So is there a hand up from someone who hasn't made an utterance yet? Yes, okay. Yes. Maria, thank you. Yeah, so maybe B calls A. So the author of B should know how A works, or they should know how to use A effectively, what information it needs to do its job, in what form that information needs to be specified, how to handle this extra parameter. Can a null be passed into it because it's only used part of the time, and if you don't need it used, the folks who use A are great people to have, as Maria says. And by that same token, what else? Things that A uses, right? So A may depend on certain areas of the system, maybe in a different layer, maybe the same layer. So it's in the business logic, kind of calls down to persist some data to the database. It calls to the data layer, persistent layer, which stores in a database or puts it on disk or whatever. And so the authors who are responsible for the pieces used by this will generally be there. Possibly testers who test this be good people to have there. Will help them learn how to test it effectively, give them ideas for tests, and let them bring up that there's a test that already confirmed, the behavior in some regard. Okay, so those are good things. Like, No, sometimes you don't have the choice. About who's available. Sometimes it's catch can. You bring in people who are available. And you'd like to bring these folks, but they're not available, or only one of them is available. And that's okay. But just think, if you have a broad choice, who might you invite and see if they're available? Make sense? Okay. Now this slide is a gross oversimplification. I put it on actually Carl Wiegers puts it on a spectrum of formality. It's actually not just one dimension. But broadly, there's big difference in the level of formality between the most informal, between certain reviews that are sort of spur of the moment, for very, a very specific meaning, need at that time, some particular occurrence where you need input, all the way to an inspection where there are roles and there's pre-review of documents and the person presenting it is not the author and people are in well-defined positions to comment on that, and it's a follow-up meeting and so on. I want to highlight that peer reviews of pull requests are one of the main ways in industry now. And one of the main ways in your projects, you're going to be doing peer review. I would like to know about those peer reviews because I want to give you credit for them. They are A1 important. Tim. I'm sorry.
Just the pull request just there, like you can't have a formal inspection of the full.
Oh, you can. You can. It's just that when you put in a pull request or merge request, I'm using the language interchangeably, you will typically you'll stipulate what are the criteria that are needed for review of it before it can be approved. Okay. And commonly those will include reviewers looking at it asynchronous. Now, you're absolutely right. When I say asynchronously, I mean, there's no formal meeting. It's like I've looked at it and, Jill looked at it and we approved. But pull requests are excellent things to inspect. If you feel that this is a big change, right? It's a substantive change, or it's at the heart of your system, or it's, folding in new complex functionality or whatever, and you want to escalate that to an inspection, that's awesome. It's just that commonly pull requests are assumed to require some sort of peer review to even be approved. That's very common. And I'm putting those in there. It's asynchronous review required to approve the pull request. Does that make sense?
Yeah, so a pull request review can be one of our reviewed artifacts.
Oh, well, no. Sorry. It can be your reviewed artifacts, absolutely. I want to know about your reviews. I want to hear. It's up, it's in your interest to communicate with me. Oh, there's programming going on. There's buddy testing going on, or the tester is sitting next to the developer and they're figuring out how to test it. That's another form of peer review. There's informal desk checks going on where someone will show someone else code. These are all good things to communicate to me, and saying that, your pull requests have had 2 reviewers for 80% of the pull requests. Like, those are things I want to know about. Those count as reviews, and those should be going on throughout your project. What is required is that each of you, sometime during the semester, have one of the artifacts you create. Requirements document, test plan, a set of tests, some code, be inspected. Okay, and I'm going to talk about inspections in just a moment in terms of what's required. But there are a more formal form of sit-down review where people are in defined roles. There's pre-review of things, there's post-review follow-up, and people are keeping track with an issues log. That's a formal inspection. That's what's required. The rest of the stuff I expect it will be going on ubiquitously, and please tell me about it. Because I want to give you credit. I want to say, wow, they're really putting effort into, they've done a lot of pair programming, awesome, or they've got 2 reviewers of most of their pull requests. That's great. That's what I'll be looking for. And I'm not just looking for numbers, like, when we say peer reviews of pull requests, I wanna see like some sort of thoughtful comment, not just looks good to me. You know. Nervous laughter, yeah, I speak from experience, painful. But I do expect those other types of peer review. And I will take the light. Take the lesson, okay? So. Code reviews based on changes like pull requests, merge requests, I expect that would be bread and butter. That would be much of your reviews are taking place in that routinized form. Just in the interest of time, I'll sort of move on here, but this is a really important slide, because it highlights the difference in the spectrum between the most informal and the most formal on this peer review spectrum. So inspections require planning, advanced preparation, meeting, that's synchronous meeting. When I say synchronous, what am I talking about? They're all going on together. It's not different times, someone going at a different time than someone else, and just communicated with messages or something. No, they're meeting for a defined time together, talking back and forth to each other, etc. It's not just at different times they're disconnected. There's corrections that are required and are often verified. Okay, that's what I'm looking for. That's what I'm looking for. Now, I'm a little bit flexible with this. The truth is, I rarely follow up with, was it verified after the fact? But I do want to know a meeting took place. It involved some planning for what would be reviewed. There was preparation, some notice ahead of time of this is being reviewed, and things got corrected. Not in the meeting, but subsequently. Meanwhile, like ad hoc reviews may have a meeting, like I asked someone, hey, could you take a look at this? There may be some correction made, but there's no advanced prep, there's no advanced planning, etc. And pair programming is just, continuous meeting, etc. Sometimes it's pre-planned, sometimes it's not. Okay, right. Now, I want to talk about these reviews that do require meetings. And most importantly, because it's required of you, inspections. So inspections typically have a moderator who sort of governs, oversees it. There's a reader who presents what is to be reviewed. Now, this is one of the areas where I'm a bit flexible. In traditional walkthroughs, that person is the author. In formal inspections, that's normally a different person. It's not the author, someone else who presents. For reasons of wanting an outside viewpoint to be presenting it rather than to avoid the sort of groupthink that might come if the author presents. Sort of, getting you to think their way. Instead of that, you want a third party presenting it, but I'm not going to enforce that. If you folks suddenly go inspecting the artifact and you want to present it on, okay, that would be okay. I don't want to add unnecessary complications, and I'm willing to give up that side of it. There should be a recorder. Things should be documented. People are in certain roles, and I'll talk about that in a moment. And there should be an issues log collected, and then with issues that are later looked into or fixed or what have you. Okay. Generally, there's a set of best practices, including like if you're doing, for Maria's comment, if you're reviewing A, it's kind of nice that B got reviewed before A, so B is working and maybe D and C have been reviewed. It's not required, but it's desirable that's using these, that you know something about these and maybe how it's being used, but probably D and C really are the things you should be reviewed, because A is using them. You do A and then you do B, so I misspoke there initially. Okay. So on the planning stage, generally you want people to have reference to the thing to be reviewed well ahead of time. And then essentially it's a planning meeting where the author says, okay, what's the goal here? We're trying to find memory leak problems in this code. Or we're trying to locate performance issues, why it's behaving slowly. Or we're trying to figure out why it throws intermittent errors. Or we're trying to see if we could make it more transparent. Because there's different goals of different inspections, and generally you want some main goals coming out of the given inspection. The rest is icing on the cake. Often the moderator gets us on. Again, I'm not going to police all of this, but you should be aware, like in formal inspections, there's often this pre-planning, the moderator's assigned who invites participants, and there's a package preparation which is then distributed to people. Okay. The prep often includes, the deliverables to be inspected, any standards for your group as far as like code style or information on testing expectations or what have you. An issue log that should be filled out during the meeting, and any other issues that might help you identify defects, like common defects for this. Products coming out of the inspection should include like the summary report, and an issues log. The summary report is like generally what was found. The issues log is what changes are needed. For you folks in your projects, when you do an inspection, I'll look for some sort of report. When I say report, give me a paragraph. Give me at least a couple sentences, like what happened, what did you find? Like, were there additional ideas for test fund? Was there some realization of ways we could test, more effectively the system using modeling? Or was there some idea found on some gap in the testing which could be remedied? Was there something found that would let you make tests break less easily as you evolve the system? Whatever. Just give me some sense, like what was the learning? In a couple sentences. If that's me for an inspection, please just don't say, these people are there, we inspected this at this time. I do expect that, but give me something that came out of it, issues were found. Now, I'm gonna say something, and I think my students in my lab are kind of surprised by it. When students tell me they find bugs in the system, when they tell me they found a defect in a model we built or whatever, my general reaction, and my reaction uniformly is, great, we found that. That's excellent. Great, we found that now. Now, there's obviously a question, how can we learn from this? How can we prevent issues like that from happening in the future? Right? And if they are going to happen, how can we find them more quickly? How can we learn about that there's a problem more quickly? Those are really good questions to ask for improving our person. But you notice I'm not coming on hard to them for having an issue with the problem with their system. I'm not saying, how did you possibly do that? It's how can we learn from this? Look, if there's one lesson to take away from this course, one lesson is that a mistake can actually put you further ahead in a good way if you can learn from it effectively and often learn how to avoid the chance of it in the future or find it as quickly as possible. Update your process. When you find a defect, of course, we think about fixing the defect, right? But even more important is fixing the process so that we can say it again, be less likely to result in a defect like that in the future, less vulnerable to that sort of defect, and able to locate it soon, know about it soon. If you can do that, having that defect has actually paid off on a net positive because now you have a better process. And that's what you want to take away. So if you folks tell me you had, you know, you did a peer review and you found 10 defects, you know, in this peer review, I'll say, excellent work. That's great, you did that. Superb. You should be asking those questions. How do we learn from it? How do we improve our process? But the point is, finding problems is a net positive. You don't want to view a problem as something which is a bad thing to find. It's a good thing to find. The same thing holds with testing. Okay, so inspection roles, I promised this to you. I've got to let you go. But author, moderator, you can read about it here. The reader, who often provides that, in inspectors, and a recorder. Okay, and I have some comments on rework after it. And potentially there's a distinguished verifier who is then meeting with the person who had created the artifact and working to fix those defects, or otherwise working to fix it. Thank you, everyone. I'll send another video or two for next week, but most importantly, I'm really looking forward to reviewing your ID1s. And oh, this is actually really important, and forgive me for just mentioning